Hello and welcome to this class. For this class, we're talking about a very important topic in physics called machine. So let's discuss machine and some basic terminologies used in machine. So we'll look at some basic terminologies involved in the concept of machine, and also we'll look at some mathematical expression of machine and solve some past questions for the last 10 years for machine. By definition, a machine is a device or tools that allows a force, that is effort, to overcome another force, which is load, applied at a particular point to another. Right? So when it comes to machine, I'm applying a force, which is effort, at a particular point to overcome another force, which is simply the word there, the load at another point. That becomes the definition for a machine. I want to understand the definition behind machine. Let's consider some basic terminologies involved in the study of machine. Let's look at some basic terminology. Let's look at some basic term involved in the study of machine. The first number one there is called the mechanical advantage. One of the first term involved in the study of machine includes, the first one is mechanical advantage. What is mechanical advantage by definition? Mechanical advantage by definition is simply, it's also called force ratio. By the way, mechanical advantage is also called force ratio. It is simply the ratio of the load acting on a body with to its effort applied at a particular point. So I'm saying that when it comes to mechanical advantage, it is abbreviated by MA. So mechanical advantage is simply the ratio of what? Load all over effort. So it becomes the mathematical expression for mechanical advantage, the ratio of load to its efforts. Of course, load is a weight, and weight is measured in Newton. So my SI unit becomes load is in Newton. Similarly, effort is a force applied on an object. So we say effort is also measured in what? In Newton. So Newton cancel Newton. Hence, there is no SI unit for what there? For mechanical advantage. So note that there is not SI unit for mechanical advantage. Why? Because Newton cancel out Newton. So I have this one here. So there are several two important information you need to know when it comes to mechanical advantage. The first one says that the mechanical advantage of a machine is influenced by the friction in the part of the machine. That's the first condition you need to know when it comes to study of machine. Also note that a machine that has no friction is called an ideal machine. So in real life sense, a machine, there's never a machine without friction. So there's no how a machine can act without friction. There's always a friction acting in the machine. But because of solving sake or problem sake, we said there's what we call ideal machine, a machine that has no friction. In real life, does not exist. But for the purpose of solving and manipulation, we actually invented the idea of ideal machine, a machine that has no friction. All right, so that becomes your first terminology in the study of machine, which is called the mechanical advantage. Let's have a second one called the velocity ratio. Let's look at second one called velocity ratio. This is abbreviated as VR, right? We said MA is mechanical advantage. Similarly, VR is used for representing velocity ratio. By definition, this is simply the distance moved by effort to its distance moved by load. That's all, right? So the distance moved by effort divided by the distance moved by load is simply the expression for velocity ratio. So I'm saying that mathematically, VR which signifies velocity ratio, is simply the ratio of what? Distance moved by effort to each distance moved by load. Distance moved by load. So it's more of saying, look up please, look up. It's more of saying effort over load. Normally, mechanical advantage is load over effort. But when it comes to velocity ratio, effort comes first before load. That becomes the concept. Similarly, it has no SI unit. Why? Of course, effort is in Newton, load is in Newton, so they both cancel out. So note that velocity ratio VR has no SI unit. A very important concept you need to know, right? So note that mechanical advantage and velocity ratio has no SI unit. All right, when I gave you the concept of mechanical advantage, I gave you two things to note. Similarly, under velocity ratio, there are about two things to note. What's the first thing? The concept of velocity ratio is that the velocity ratio of a machine does not depend on the frictional force. Rather, it depends on the geometrical construct of the object or the machine. So when it comes to mechanical advantage, it depends on the what? The friction, right? That take part in the machine. But when it comes to velocity ratio, it does not depend on frictional force. Rather, depend on the geometrical construct. That becomes your first concept you need to note in the study of, or perhaps in the concept of velocity ratio. Also note that for an ideal machine, listen up, we said an ideal machine is a machine that has no friction. Similarly, I'm saying that for an ideal machine now, its mechanical advantage is equal to velocity ratio. So I'm saying that for an ideal machine, machine, velocity ratio VR is equal to MA. A very important concept. We use it in our solving some problems, right? Know that when a machine is in ideal state, it has no friction. It means that velocity ratio is equal to mechanical advantage. All right, let's proceed at this point. We have discussed machine, velocity ratio. Let's look at the third terminology called efficiency. Efficiency, abbreviated as E, capital E. All right, let's look at efficiency, please. By definition, efficiency is simply the ratio of mechanical advantage to its velocity ratio expressed as a percentage. What do I mean? So when it comes to efficiency, I'm combining both mechanical advantage and velocity ratio in terms of percentage. What do I mean? Mathematically, I'm saying that efficiency E is equal to the ratio of mechanical advantage, that is MA, on over what? Velocity ratio, that's VR, expressed in terms of percentage. That becomes multiplied by 100%. This becomes your mathematical expression for efficiency is equal to the ratio of mechanical advantage to its velocity ratio multiplied by 100%. So note that when it comes to mechanical advantage, the formula there is what? Load over effort. When it comes to velocity ratio, the idea is that effort comes before load, but in terms of what? Distance. I have distance moved by load over distance moved by, distance moved by effort all over distance moved by load. I have this one here. Similarly, we said efficiency is the ratio of what? Mechanical advantage to velocity ratio multiplied by 100%. At this point, aside this formula for calculating mechanical efficiency, note that efficiency E can be expressed as the ratio of work output, all over work input. Also note that mechanical advantage can be expressed in terms of work output sorry, work output all over work input times 100%. So note that efficiency can be expressed in terms of MA over VR, or work output all over work input times 100%. What do we mean by work output? What do we mean by work input? First things first, let me give you the expression for work output. Work output is simply the multiplication of load times distance moved by load. So note that to calculate for work output, is the idea is that I'm multiplying load multiplied by the distance moved by that load. So if I have a load here and I actually push the load at a particular distance, to get the work output, I'll multiply that weight of the load and the distance I covered or traveled by that load. That becomes how to calculate for your work output. For your work input, then work input becomes your effort times distance moved by effort. I have distance moved by effort. This becomes your mathematical expressions and what you need to know basically for a machine, right? So I've given you several formulas for calculating a machine, and also we'll look at how to apply this formula in solving some past questions for the last 10 years. All right, at this point now, let's look at several questions, and let's look how to solve both JAM and WAEC, and also several questions, and let's see what we get. Welcome back. Let's try to solve some problems under the concept of machine, and let's see what we get. Question 1 says a machine of velocity ratio 6 requires an effort of 400 Newton to raise a load of 800 Newton through 1 meter. Find the efficiency of the machine. Option A is given as, my option A there is given as 50.0%. Option B 50.0%. Option B there, I mean 22.2%. Option C, I'm having 33.3%. Option D, I'm having 55.6%. Let's look at how to solve this particular problem, and let's see what we get. The one says, we said your first task in science is that after reading out question, you should what? List out the given parameters. What are you given? This is first solution for that question there. What am I given? Number one there, I'm getting that a machine of VR, that's velocity ratio, I'm given the velocity ratio VR has been equal to 6. Requires an effort of 400 Newton. So I'm given effort has been equal to what there? 400 Newton. All right, to raise a load of 800 Newton, I'm given load has been equal to 800 Newton. All right, at this point here, what next? So find the efficiency. So I'm looking for E, efficiency. E is unknown. So first things first, my task here now is to get efficiency, right? When it comes to efficiency, I gave you two formulas in terms of MA over VR, and I gave you in terms of work input over work output. Here now, I can apply the idea of work output over work input. It cannot work here because I'm not seeing anything like work here. So I'm going to apply the very first formula I gave you for efficiency. So at this point now, recall that we establish that efficiency E is equal to mechanical advantage all over velocity ratio times 100%. Look up, I'm given VR, no problem. Am I given MA? No. So my task now is to get MA. If I know MA, I can easily look for what? Efficiency. Now, the problem here is that I need to know MA. How do I get MA? Recall that we established that mechanical advantage MA is what there is load all over effort. That's all. Check your notes, it's there. I gave you this. So from here now, what's load? We said load is what there? 800. I have 800 divided by what's effort? That's 400. I have 400. At this point, divide 800 by 400. Mechanical advantage here, MA, is equal to 2, right? So I have 2 here. Now here's the task. To get efficiency, I need 2 things. Number 1 is what? Mechanical advantage. Number 2 is what? Velocity ratio. So I've seen my value for MA. My MA now is 2. Now my VR is given as what? 6. So let's get our efficiency. From here, efficiency E, mechanical advantage all over velocity ratio times 100%. Efficiency E is equal to, what's MA? That's 2. So I have 2 all over. What's VR? Of course, that's 6. So I have 6 here, multiplied by 100%. From here, efficiency E is equal to 1/3 times 100%. From here, efficiency is equal to, if you put the calculator from here, you have 33.3% as being your answer. So check our option here. My option there is option C. So option C is my answer for this particular problem. Let's do example 2 to further explain the concept of machine. Example 2. Example 2 says that a machine is used to lift a load of 20 Newton through a height of 10 meter. Full stop. If the efficiency of the machine is 40%, how much work is done? Listen up, how much work is done? My option there is given as option A is given as 300 joules. Option B there is given as 120 joules. Option C, I have about 80 joules. Option D there is about 500 joules. Why is it in joules? Because we're going to calculate for what? Work done. I know that the S sign for work done is measured in what? Joules, right? So let's look for the work done here. We said your very first task in science is what? List out the given parameter. What are we given? So solution, my first thing there that I'm given, what am I given first? My first thing there is given as a load of 20 Newton, right? I'm given load LOAD of what? 20 Newton. Listen up, please. Listen up. Through a height of 10 meter. So listen up. That height becomes distance moved by load. Listen up. So I have number 2 there. I'm given the distance. Distance moved by load has been equal to 10 meter. Next up, if the efficiency, I'm given the efficiency of machine. Number 3, I'm given the efficiency, that's E, capital E, has been equal to 40%. Now the question says how much work is done. Listen up. At this point now, listen up. There are 2 types of work I give you. We said we have what we call the work output and work input. Now here's the question. Take a little bit and think. I'm looking for work done here. Am I looking for work input or work output? Which one exactly am I looking for? Think of that for a little bit. Think of that. So which work done I'm looking for? Am I looking for the work output or work input? In this case here, listen up. I'm given load and distance moved by load. Load and distance moved by load represent what? The work output. Check the formula I gave you earlier that work output is simply load times distance moved by load. So in this case here, I'm given what? Work output. So it means that I'm looking for what? Work input. That becomes the concept. I'm looking for work input in this case now. So solution, how do I solve this one here? My task here is quite simple, right? It's quite simple. My very first task here is to get my, what's it called? Work done, right? Per se, from this point, recall that we said efficiency E is equal to work output all over work input times 100%. So I'm saying that I'm given work output. How do I know? No, we said work output is simply the product of what? Load and what? Distance moved by load. No problem. So from here, let me get, we know that we are looking for work input. No stress. Let's get work output. From here, work output is equal to load times distance moved by load. So from here, what's my load? Load is of course 20 multiply distance moved by load is what? There is 10. Multiply the 2. My work output is equal to 200 joules, please. So note that anything work output or anything work is not in joule. So I have 200 joule. Yeah. So at this point now, I can easily get my work input, right? Because I'm given efficiency. Efficiency is what? 40%. Yeah, almost done. So efficiency is 40%. So from here now, efficiency E, that's 40%. Efficiency 40% is equal to work output, which is what? There 200 all over work input that I'm looking for. Let's say work input. Let's call it W high if you want to reduce the space. So times what? There 100%. Of course, percent cancel out percent. And what is what? 40 is equal to 200 all over work input times 100. Multiply these two, I'll have work input. I'll have 40 work input is equal to what? There this is 20,000, right? So divided by 40. What do I get? 40 cancel this. What's my work input? Work input is equals to this, cancel this, right? So that's 500 joules. So of course my answer here is option D, 500 joule. It becomes how to calculate problems under machine. Next class we'll try to look at the concept of inclined plane and other aspects of machine in the next class, right? So if you're interested in joining our WhatsApp group, I just created a WhatsApp group whereby several students from different countries can easily combine together to share it there. If you're interested in joining this WhatsApp group, I'll drop the link in the description of this video. So check the description of this video. You see the link there. To see you in the next class. Share to your friends and classmates so they can learn too.